Hey everyone, and welcome to The Explainer. I'm really glad you're tuning in today because we are going to tackle something that is literally the lifeblood of any successful business, and that is figuring out production costs. We aren't just going to look at the massive, intimidating overall numbers either. We're going to break down per unit production costs into totally manageable, bite-sized pieces. Seriously, whether you're building a startup, cramming for an econ exam, or you just love understanding how businesses actually make money, mastering this is kind of like getting the secret decoder ring to profitability. So, grab a notepad, get comfortable, and let's demystify these costs together. Okay, let's run through our roadmap real quick. First, we'll hit the basics of production costs, then average fixed cost, average variable cost, average total cost, and finally, we'll wrap it up by looking at the cost curves explained. Section 1, the basics of production costs. Before we even touch any formulas, we really need to understand the basic ingredients required to make, well, absolutely any product in the short run. Imagine we're opening a business making children's toys. To make these toys, we need two very different types of ingredients, or what economists like to call factors. First up are fixed factors. These are things you can't easily change in the short run. Think about your factory building, the heavy machinery, or your permanent managers. You have to pay the rent on that factory space whether you produce one single toy or 10,000 toys, right? Then we have variable factors. The supply of these changes instantly depending on how much you want to produce. For a toy factory, this is the plastic used for the toys or maybe the wages you pay to temporary casual workers. If we want to make more toys, we immediately need more plastic and more hands on deck. So the costs associated with these rise and fall directly with our level of output. Moving right along to Section 2, average fixed cost. Now that we've got fixed and variable factors down, let's look at our first specific per unit cost concept, average fixed cost, or AFC. Simply put, this is the per unit cost of those fixed factors, and you calculate it by dividing your total fixed cost by your total output units. Honestly, this is just a really fancy way of saying we're taking those stubborn, unavoidable expenses, like the factory rent, and spreading them out evenly over every single toy we actually manage to produce. The crucial takeaway here is the formula. AFC equals TFC divided by Q. Definitely write this one down because it's your very first mathematical tool for understanding business efficiency. Let's decode that so it's not just alphabet soup. TFC stands for total fixed cost. This is your total rent, your insurance, the equipment. And Q is your total output units, so the number of toys you made. The logic here is pretty mind-blowing when you think about it. Say your factory rent is $1,000. If you only produce 10 toys, the average fixed cost for each toy is a whopping $100. That is a very expensive toy. But if that rent stays exactly the same and you suddenly ramp up production to make 1,000 toys, boom, your rent cost per toy becomes just one single dollar. As your output goes up, your average fixed cost continually gets smaller and smaller because that big, heavy fixed burden is getting spread over a much larger crowd of units. All right. Section 3, average variable cost. Awesome. We've tackled the fixed costs. Now let's completely switch gears and focus on the changing expenses. Average variable cost, or AVC, is the per unit cost of your variable factors. You get this by dividing your total variable cost by your output units. Remember those variable factors from earlier? The plastic, the electricity running the machines, the temporary workers? This specific metric isolates exactly how much of those changing costs go into producing just one single item. And the formula you'll need for this one is AVC equals TVC divided by Q. Let's run through these variables really quick. TVC is your total variable cost, and Q, as always, is your output units. Keep in mind, unlike your rent, total variable costs never stay still. Every single new toy you decide to produce requires brand new plastic and extra electricity to run the molds. So as more items are produced, your total variable cost goes up directly. Dividing that total by the number of units gives you a crystal clear picture of the variable expense tied to a single unit. Which brings us to Section 4, average total cost. So we have our fixed pieces and we have our variable pieces. Now it's time to mash them together. Average cost, AC, or average total cost, ATC, and those mean the exact same thing by the way, is the per unit cost of both combined factors. You find it by simply dividing total cost by output. This brings together absolutely everything we just learned. It is the final, ultimate number that tells a business owner exactly how much it costs, on average, to produce one completely finished item. The formula for this is beautifully simple. AC, or ATC, equals TC divided by Q. Let's break that down. TC is literally just your total cost. And how do you find total cost? You just take the total fixed cost we talked about earlier and add it directly to your total variable cost. Once you have that grand total of all your expenses, you divide it by Q, your total output. This right here gives a business its true baseline for profitability. I mean, if your average total cost to make a toy is $5, you absolutely know for a fact you have to sell it for more than $5 to make a profit. It is easily the most vital number in the room. Section 5. The cost curves explained. Let's see how all of this plays out in the real world. Formulas are great, right? But economists and business leaders usually love to actually visualize this data. So let's translate our math into cost curves. Imagine a graph. On the bottom axis, the x-axis, we're measuring our output, the number of toys we're making. On the vertical y-axis, we're measuring the cost. If you look at the AFC curve, the average fixed cost, it starts way up high on the left and continuously swoops downward. Then take a look at the AVC curve and the ATC curve above it. They both have this very distinct swooping U-shape, where they dip down before rising right back up again. There are a few really vital economic narratives hidden in these curves. First off, notice how that AFC curve falls constantly from left to right. As we spread our fixed factory rent over more and more toys, the cost per toy shrinks. But notice something kind of weird? The curve approaches the bottom line, but it never ever touches zero. Why? Well, because as long as you have some fixed cost, even a single penny, dividing it by any number will never equal exactly zero. Next, look at that U-shape of the average total cost and average variable cost curves. They drop initially, hit a minimum point, and then start climbing again. This happens because of something called the law of variable proportions. At first, adding variable factors, like extra workers, to your fixed factory makes things super efficient, so your average costs drop. But eventually, the factory just gets too crowded. Adding more workers actually makes everyone less efficient per unit, which forces those average costs to climb right back up, hence the U-shape. Finally, check out the vertical gap between the top curve, ATC, and the middle curve, ABC. As you move to the right, churning out more output, that gap gets visibly smaller and smaller. And guess what? That gap is exactly your average fixed cost. Because your AFC is getting tinier and tinier as you produce more toys, the average total cost naturally gets closer and closer to the average variable cost. But since AFC never actually hits zero, those two top curves will never truly touch. It's just a brilliant visual balancing act. Which leaves us with a pretty fascinating puzzle for today. If average fixed cost never entirely reaches zero, no matter how much you crank out, and the average variable cost curve eventually has to rise because your factory gets way too crowded and inefficient, at what exact output level is a business running perfectly? Where is that absolute sweet spot for maximum profit? It's this complex balancing act where you want to produce enough to make your fixed costs basically zero, but not so much that your variable costs skyrocket out of control. Finding that exact point on the U-curve is the daily obsession of basically every great business mind out there. I really hope this breakdown helped you see the underlying logic behind production costs. Thanks so much for joining me on The Explainer today, and keep asking those great questions.